You guys remember in your last homework you did like m squared, or m times m bag here, and then m squared? You guys remember that question? I know some of you guys actually worked that out, which you didn't have to, but if you did, then it's a very difficult problem to do. And eigenvalues, eigenvectors kind of help us to make it a lot easier, so we don't have to go through all those matrix multiplications, and rather we can do something else a little more easy. So this is very helpful for future applications. I know you guys don't really see the use for it right now, which is fine. I didn't really understand the point of linear algebra when I first took it, but it's very useful when you get to more higher level classes. Okay, so it's good to get a decent foundation right now. So I thought we'd do a quick problem because this is a short lab. We're not going to be doing anything code intensive, mainly just concept based. So just to help you guys understand this with your test coming up too, right, next Monday. Maybe we can just review the concepts and help you with your code as well. So we're going to start with this question. I'm not going to solve it for you. I want you guys to kind of not really decide on how we find the eigenvalue. Okay. So anyone want to help out? Have a go. Anyone got a small idea?
You find a characteristic equation.
Okay, so how would that look like in this case?
I don't remember.
You don't remember? Okay, so just think of this being multiplied by xy, so you're on the right track. So now I'm just going to do xy here. Xy here. So then we're just going to multiply it out and get a linear combination, I guess, right? So then this becomes x plus 2y and 4x plus 3y. So a bunch of variables. So what our goal here is to try to get it in terms of x or y, and then plug it into another in terms of x or y. And I'll show you what I mean by that in a second. So the first thing we're going to do is I'll just take this one first. And I'm going to turn it into something that we can substitute into later. So I'll say lambda x is equal to 2y over this. Okay. I'm going to say 2y is equal to lambda x minus x. So I just subtracted x on both sides, so I get to this point. And I'm going to divide by 2. And that's going to be equal to lambda x minus x over 2. And that's 1. I could simplify it, or I could take out the x, but I'm just going to leave it like that. So we have something in terms of y. Now we want something in terms of x from this equation, so that we can plug it into here and then get some demonstrate or some representation of lambda. So I should make this picture smaller. Right. It's very nice. So then now what I'm going to do is I'm going to say 4x plus 3y is equal to lambda y. Now does anyone know what we do here? Like I said, we make a representation of y or x, but how do we do it? Minus 4y?
Or minus the 3y.
Oh, minus 3y.
And divide by 4.
Yeah. So then I'll just skip to the end. So then lambda y minus 3y over 4. So now we have something in terms of x here with lambda and y, and something in terms of y here with lambda x. So what we can do now is we can plug into either one. I think the easier one would be to just plug in, it doesn't matter, it's the same. So I'm just going to plug in y into here, okay? So every instance of y, I'm going to plug in x, but since we can distribute out y, this is also equal to y lambda minus 3 over 4. So we can just plug it in once. So then it's going to become lambda, x lambda minus 1 over 2, lambda minus 3 over 4. So is anyone confused on this part? Right here? No? So I just substituted in for x or y. Now I'm just going to simplify more. I end up with x lambda minus 1, lambda minus. Alright, now this part's a little tricky, so what I'm going to ask you guys to do is I just want you to talk to your next door neighbor and then figure out maybe a solution to it. And if you can get to the final answer, that'd be great. So just talk to your neighbor for like a second, I'll talk together. And then we can figure out the answer.
one part in the last